Hi everyone, welcome back to another video lecture from Mrs. Semino. In this video, this is the part 3, so maybe I should write part 3 here. And this one we're going to be talking about the multivalent ions. So before we dive into like the definitions and stuff like that, again, let's just break down the word. Multi, again, can mean many, right? And valent, I'm hoping that's making you think of like valence electrons. And then again, ions means it has a charge on it. So the idea is that there's some metals that can have more than one charge. So like before I kept using calcium, that's usually like my go-to element. Calcium is always going to have a 2+ charge. But there are going to be some elements that can have more than one charge. So for example here, iron can be a 2+ charge, or it can have a 3+ charge, okay? And ideally these are going to be on your polyatomic ion sheet, so check that out and see where those are located, okay? So like I said, a multivalent ion is a metal that can have more than one charge, okay? Most multivalent ions are found in the transition metals, but not all transition metals have more than one positive charge, okay? So remember when we're talking about the periodic table here, okay, so that transition metal section is here, and there's a couple that kind of appear over here too. So those are the ones that are going to be multivalent, but not every single one that's in our transition metals has a charge. So the idea here is that silver is only has a +1 charge. Zinc only has a +2 charge. And if you're using my polyatomic ion, these are on the back side of the polyatomic ion sheets at the top, the ones that have like only one charge. And it's kind of tough to tell what charge it is because we can't use like the reference system that we normally use. Okay, so if you look on the back of my periodic polyatomic ion sheet, you should see this. So it's not like you have to write this down, so don't start writing all this down. But you can see here, I've got chromium. Chromium can have a 2+ or a 3+ charge. Cobalt can have a 2+ or a 3+. Copper, 1+, 2+. So there's several, and there's actually even more than these. There's more than these, but these are just like the most common that I use in my class. And then the idea here is you can see all the different elements. Okay, you can see that they have multiple charges that they can have. And then if you look over here, I put 2 columns, the systematic names and the common names. The systematic name is what we use now. It's like, it has like more of a shocker system to it, kind of like an organization to it. So the idea here is you want to look at this, I'm going to zoom in here a little bit. So if you look here, this Roman numeral means a 2, right? And then if you look here, this is a 2+ charge. Again, this guy has a 3, so this would have a 3+ charge. So this is the thing that the kids have a really hard time with, is that these Roman numerals are actually the charge on the metal, okay? Metal. And then over here, if we look at the common names, okay, the common names are kind of just like the old-fashioned names. And so like chromis or chromic, okay? And then like cuprous and cupric or ferrous and ferric, okay? So the idea is you might have heard some of these names before. And this is kind of just like their old-fashioned names. We don't really use them that much anymore. But one thing I do want to point out with these is notice how it's like OUS and then IC, OUS and then IC. So do you see that trend there? So the OUS, okay, means it has a lower charge, okay, and then the IC means it's the one with the higher charge. Now let's go ahead and look at some examples for these. So in this first example here, it says 10,2 oxide, and then you obviously can see the formula here. There's going to be a slide in a second where you're going to have to do this on your own. So the idea here is that the 10, okay, SN, is going to have a 2+ charge. Oxygen, the oxide, would have a 2- charge. So you guys seeing how those two would cancel out, and so that's why I can just write SNO. Okay, now if we look down here at this one, the 10,4 oxide, this would be SN with a 4+ now, because that's what the Roman numeral tells us. And then again, oxygen is going to have a 2- charge, so you can see that we're going to need 2 of these oxygens to make the -4 charge, and so that's why this would be SNO2, because I needed 2 of the oxygens. Then you can see the see this with the example with these other ones. So this is chromium 2, chromium 3. So the idea here is because the Roman numeral or the charge is changing, the chemical formula is also changing here. So chromium 3 plus, nitride would be 3 minus. Oh, I think I did that backwards. Oops, my bad. Hang on a second. This is a 2 plus. I was like, this is not making sense. Okay, so since this is chromium 2, and then nitride has a 3 minus charge, you can see that we're going to look for the lowest common multiple, which is 6, which is why we'd need 3 chromiums and 2 nitrogens. And then down here, chromium 3 plus, nitride 3 minus, those charges are canceling out, so that's why we can just write CRN. And here's the page where you practice yourself. So go ahead, pause the video, solve them, and then come back and look for the answers. Okay, so when we look at this one, okay, we have iron 3, or 2, iron 2, iron 2 here, and then Fe2 plus, and then oxygen would be 2 minus, so you can see that they would just cancel each other out. Here, I would have Fe3 plus and oxygen, so again, we're going for that lowest common multiple of 6, and so that's why it's going to be Fe2O3. If we have copper 1 nitrate here, this would be Cu1 plus, and the nitrate, that's a polyatomic ion, and you know that it is because it ends in ATE here. Again, those charges are balancing each other out, so you just need 1 copper and 1 nitrate. On the other hand here, if you had copper 2 plus and nitrate, you can see that these charges are not balancing out, so you'd need 2 of the nitrates for them to, for the charges to cancel out so that your compound can be neutral. Now, when we go to name these compounds, we're naming them just like we did before, except for the new thing we have to include is the Roman numeral. So you want to make sure that you're including that Roman numeral, okay, here. And we don't include the Roman numeral for every metal ion, only for those ones that are the multivalent, so those ones that appear on your sheet. So as we go ahead and look at this one, you can see that it is copper and then sulfate. But now the question is, like that a lot of my kids ask is like, well, how do I know that it's going to be a copper 2 sulfate? Well, you can just kind of write it out on your paper and then see what the metal ion would need to be to balance out the charge. So for example, I've got copper. I don't know what copper's charge is, but I do know sulfate's charge is 2 minus. So in order for this to be a neutral compound, which it is because I don't see any charge here or anything like that, then the charge on the copper would have to be a 2 plus charge. It would have to be a 2 plus charge. So that's where I got this from. And then we can do the same thing down here with the cobalt sulfate. Let me just get a different color real quick. Okay, so cobalt would be question mark. We don't know what that charge would be. And then sulfate, SO4, 2 minus, we know that charge. So when I look at this, I'm seeing that there's 2 cobalts. Oh, and I should have made that O like a little smaller there. Okay, and then there's 3 sulfates. Or maybe I should have chosen a different color for this. But hopefully you're seeing that these sulfates are adding up to -6 over here. So if I only have 2 cobalts, this has to be +6. So what would the charge on each of the cobalts have to be? It would have to be a +3. Okay, so just like we've been doing, here's some practice problems. Go ahead, pause the video, solve these, and then come back and see the answers. Okay, so let's check these out. Okay, so this first one here, we've got lead 2 oxide. Again, the question is, how did we know we got the 2? Well, I've got 1 lead, I've got 1 oxygen. I know the oxygen has a 2 minus charge, so my lead would have to have a 2 plus charge to balance out. So that's where I'm getting the 2 plus. Okay, over here with the copper 3 here, the copper 3, and then the phosphate that we have here. I know I have 3 coppers, so I'm just going to write them out like this. and then I know I've got one phosphate. So I don't know what the charge is on each of these, but I do know that they're going to have to add up to be positive 3. So that again, that when we add these, oops, sorry, I didn't mean to move that. Um, uh, okay, so when we add them up, they're going to be 0. So what is the charge on each copper going to have to be? It's going to have to be 1 plus, so that it adds up, all those 1 pluses add up to be 3 plus. So that's why we're going to call it copper 1, because that's the charge on each of the ions. Then when we look over here, nitrate, we have 3 of them. So we know that that's going to be minus 3 because there's 3 nitrates. So your iron would have to be a positive 3. And then down here, the lead 3 phosphate, the same thing. You only have 1 lead, but you know the charge on phosphate's 3 minus, okay? So lead would have to be a 3 plus here. Okay, so as we did this one, just as a reminder, you guys, a multivalent metal ion is really most likely going to be a metal, and it is a metal that has more than one charge associated with it. And so like we saw, like lead can be lead 2 or it can be lead 3, okay? Copper can be copper 1 or it can be copper 2. Iron can be iron 2 or iron 3. So since they have multiple charges, we have to include these Roman numerals in the names. Or when we see the names, it actually makes our lives so much easier because we know exactly what the charge is on the metal there. Okay, so when we write the formulas, we're writing them the same exact way. We're just balancing the charges. And when we name them, like I said, we're including these Roman numerals in those names. Please make sure you guys write down any questions and ask me in class.